Hi folks, it's Williams. Today's topic is in behavior of polynomials. First thing we need to talk about, make sure you have your notes pulled up from the images in Google Classroom. First thing we need to talk about is what a polynomial is. So a polynomial is a function that has only whole numbers for exponents and doesn't have anything like logarithms or trigonometric functions that sine, cosine, tangent, or exponentials or anything like that, and nothing special. So this first one is a polynomial because the exponents are all whole numbers and there's nothing special about it. The second one is not a whole number because it has an exponent that is a fraction, and that's not a whole number, so this is not a polynomial. This third one, function n, is not a polynomial because it's got a logarithm in it, so that can't be a polynomial. Function n has sine in it, that's a trig function, so that's not a polynomial. Function q has a negative exponent. Negative numbers are not whole numbers. Negative whole numbers are called integers. Those are not called whole numbers. So this does not have, this has an exponent in it that is not a whole number, so this is not a polynomial. So when we are talking about polynomials today, we are going to be talking about end behavior. According to your notes, the end behavior is what happens on the left end of the graph as x goes toward negative infinity, and on the right end of the graph as x goes toward positive infinity. I gave you some things that the end behavior could be. It could go up forever, it could go down forever, it could approach a value, it could approach a line, or, and I'm not sure if this one's in the notes, but it also could end and not go toward infinity or not go toward negative infinity. Those are the choices in general, but for polynomials there's only two choices. There's up forever and down forever. So the left end can go up forever, or the left end can go down forever, the right end can go up forever, or the right end can go down forever. And there can be any combination of left and right. It can be left and up, left and up, right and down, left and up, right and up, etc. So we need to talk about how to determine what that end behavior is going to be from the equation, from the function rule. So there are some rules that I gave you. If the leading coefficient and degree, forgot about that. We need to determine what the leading coefficient and degree are to do this. So the degree is the highest exponent. The leading coefficient is the coefficient of the term with the exponent. So if you see the degree, the highest exponent, look in front of it, that's your leading coefficient. If we have a positive leading coefficient, the right end goes up forever. If we have a negative leading coefficient, the right end goes down forever. This is in your notes. If we have an even degree, the left end goes the same direction as the right end, as far as up or down. If we have an odd degree, the left end goes the opposite direction from the right end, either up or down. So let's look at some examples and see exactly what we mean by this. Okay, so we've got this function at the top, function f. I've got this 4, that is the highest exponent. My degree is 4. I've got my leading coefficient is the coefficient that is in front of that. My leading coefficient, which I'll often abbreviate LC, my leading coefficient is 3. If you look at your notes, it says that a positive leading coefficient means the right end goes up forever if the leading coefficient of the polynomial is positive. And then we saw that an even degree, 4 is an even number, we saw an even degree means the left end does something different from the right end. Sorry, something the same as the right end. So the left end, because the degree is even, does the same thing as the right end, which means it also goes up forever. The left end is determined by both of these, blue and red together make our purple. Okay? Leading coefficient being 3, that is positive, so that means that the right end goes up forever. The degree is even, which means that the left end does the same thing as the right end, goes up forever. And if we graph that here on Desmos, we can see that that is true. Our right end does keep on going up, and our left end does keep on going up. It goes left. Okay, so if I change anything on this, As long as my degree is even and my leading coefficient is positive, end behavior will stay the same. If I change that to 31 for leading coefficient, this end behavior is the same. The right end goes up, the left end goes up, because I didn't change either of my rules. I didn't change the leading coefficient from positive to negative, and I didn't change the degree from even to odd. If I do 2, the end behavior is the same because that leading coefficient is still positive and the degree is still even. I didn't change either of those things on my rules. If I look at this next function G, and I look for the degree for the highest exponent, this degree is not 4. Yes, there is a 4 here. That is my first exponent, but that's not my largest exponent. My largest exponent is 6. So this 6 is my degree. My leading coefficient comes in front of that. It is the -7. Because the leading coefficient is negative, that determines the right end. The right end goes down forever. The right end goes down forever because the degree is even, the left end does the same thing. So the left end also goes down forever. So the leading coefficient determines the right end. The degree determines whether the left end does the same thing as the right end or the different thing from the right end. By the way, in case you don't remember from earlier, by same or different, I mean up forever and down forever. Okay? Let's check Desmos and see if this does what we said it would. The right end does go down forever and the left end also goes down forever on this one, just like we said it would. If I change this degree, I can change the degree, that highest exponent, to anything I want to. As long as that highest exponent is still even, then that does not change my end behavior. I can change my leading coefficient to anything I want it to be. As long as that leading coefficient is still negative, so -1, -2, -3, -4, -5, as long as that leading coefficient is still negative, my end behavior does not change. If I change this to an exponent of 2, that does change the end behavior, and the reason why is 2 is not my highest exponent, 4 is my highest exponent. So if I do this, my degree is now that 4. The leading coefficient is now this 2, and it is positive, so that means that the right end goes up forever. The degree is an even number, so that means the left end does the same thing. It goes up forever. When we're looking for the answers on this, this is going to be the answers that I'm looking for. Now there is a way to write this with limit notation. The limit of g of x as x approaches right end is positive infinity and up forever is positive infinity for the y. Okay? You don't have to put positive there. So this x is approaching is talking about left end or right end. I gave you some notes that said x approaches infinity is right forever, x approaches negative is infinity is left forever. And this value, this y value right here is our up forever or down forever. So positive infinity is up forever and negative infinity is down forever. And you can combine the left, right, and the up, down in any way you want. So left and up, left and down, right and up, right and down. I will not make you do the limit notation for your answers. All I'm going to be looking for is the words right forever, up forever, and such. So this one, if you look at this, we're still looking for our degree. Our degree is our highest exponent, which in this case is 5. Our leading coefficient, which I abbreviate LC, got 5 there. The leading coefficient comes before the degree. It is this 4. My leading coefficient determines my right end. Because it is positive, because the leading coefficient is positive, my right end goes up forever. My right end goes up forever. My degree is an odd number. Because the degree is an odd number, the left end does different from the right end. Different from up is down. Down forever. And we can check and see if this is true. If we graph this, indeed, the right end goes up forever and the left end goes down forever. I can change this function, and as long as I don't change the fact that the leading coefficient is positive and the fact that the degree is odd, then my graph's end behavior will not change. I can change that to a 7. The degree is still odd, so the end behavior is the same. I can change that exponent to a 9. The degree is still odd, so the end behavior is still the same. I can change that 4 to a 42. The leading coefficient is still positive, so the end behavior is still the same. I can change that 42 to a 2. The leading coefficient is still positive, and the degree is still an odd number, so the end behavior is still the same. Last one is function j. Function j, my degree, my highest exponent is this 5. My leading coefficient in front of that is -5. Right now I suggest that you pause the video and predict for yourself, according to the rules, what is going to happen here. So pause the video and think for a second. Okay, hopefully you paused the video and thought. Because our leading coefficient is a negative number, that means the right end goes down forever. Because the degree is an odd number, the left end is going to do different from the right end. So the left end goes up forever. Different than the right end because the degree is odd. So that's it for today. Email me any questions that you have. Until next time, be well, do good.